Great. I'm Sam. I will be talking about bytes in the browser, how to handle non-text data simply. So a little bit about me. From Chicago originally. I love clean code, scotch, beer, and I want the web to win. So some background about how I learned about handling binary data in the browser. We were working on a web app where we had to generate PDFs on a server, basically on demand, and then send that to the browser. And if you remember in 2009, IE8 was not a thing. Firefox 3 had just come out. Chrome was released like 3 months before and nobody used it. And it was a dark time. IE7 roamed the earth. So what we were doing was we were working on an app in Dojo, if any of you remember Dojo. And so the entire thing was all Ajax-y with widgets. We would have a button that users could click, export this to a PDF, and we would off in the background say, like, great, we're generating this, and then give it to them when we finished. But the problem was that the server side was slow. If you remember 2009, this was like pre-Vista. It was ridiculous to expect that a desktop would have a gig of RAM. So the server side was slow. Also, our clients were like banks, telecommunications companies. So they would have millions upon millions of records, and there was no graceful way to handle the file once it came back. So basically, people would click, like, I'd like this as a PDF. And sometimes that PDF that we generated would be 40 pages long, and it would come back 7 minutes later. And you know, the person would have forgotten that they requested a PDF, and it would be a form submission, so we would just interrupt everything they were doing and just be like, here's that PDF that you requested. And if there was another PDF that they had requested, who knows? So what did we do? We wept, cursed bitterly, and drank. What we actually did was we tuned the server side so that the PDFs would just generate faster. But that didn't really get us around our main problem, was that we were doing everything asynchronously, and this was a purely synchronous task because we couldn't just give callbacks. What we needed was, if you know jQuery, this would just be a post of the form, and we would get the PDF back. But this was 2009, and browsers didn't know what PDFs were. So we would get a string, and it would be literally a PDF. It could be upwards of a megabyte, and regardless of what we got back, there was nothing that we could do with it, because we would load it into a new tab, and people would just get like a megabyte of text. And that was quite typically opened as a defect against the product. However, later that year, Aaron introduced the file API, and that became a W3C recommendation. So it wasn't great at the time, but it was a great start, and it showed that the standards bodies were listening. So that brings us to today's API, which is far better than it was. It allows you some limited local file system access. It has improved network transmission, and it gives you new binary data types that you can work with. So I'll talk a little bit about these. With local file access, we get two new functions, or I guess types. One is the file, and one is the file reader. It's safeguarded because to use either of these, you have to basically use file inputs from a form. So it's not like we can just fire up a browser, roam your file system, and then access everything. Also, we don't get paths when people use files. You get the file name last modified, and everything is read-only. So we can't overwrite anything on your system. Sorry, am I talking too quickly? You can let me know if I'm kind of flying through this. So the file, it allows you to grab metadata. So think if you're using Jira and you're trying to upload a screenshot of a recent bug. We have access to the last modified date. So we could say, hey, this is from last week. This probably isn't the screenshot you just took. So it allows improved user experience in the browser through that. But to actually use the data, we use the file reader, which has an API. It's basically identical to the XHR API you're used to. Asynchronous handlers can read into array buffers, which I'll talk about, text, which is just strings, and data URLs, which is like a base 64 encoding of the binary data. So if you've dealt with like SVGs with embedded images, you've probably seen that. So the improved network transmission is that it allows you to specify new data content types. You're probably used to JSON, HTML, XML, or just plain text. We add Blob and array buffer. And we get two new data types, Blob and array buffer. So a blob is sort of opaque data in the browser. It's great if you don't want to do anything with the data yourself. If you don't want to reach into it, you just want like a wrapper that you can pass around to someone who knows what to do with it. But array buffers are great. They can be sliced and typed. And this is really where the magic comes from. They can be sliced because with an array buffer, everything has to be in memory. So unfortunately, when you're dealing with a 10 megabyte file, you have to have 10 megabytes in your computer's memory. But you can slice those. So you can create basically sub-array buffers of like grab the first 2 megabytes, pass it off to a worker, and then free everything. So those 2 megabytes that you passed off, they aren't freed when you free the parent array buffer. So you can divvy up data, pass it off to workers, and then say, I don't ever want to think about this anymore. And the workers can work and then just get their data back, or they can free their data whenever they're done with it. It really simplifies memory management. It makes things way more efficient. And then they can be typed. So you can have basically integer arrays, and you can have untyped integers of all sizes, which adds a great deal of granularity. So you could implement a stream reader of heterogeneous data. This is just, you pass in an array buffer, and then you can just grab, an integer of any size. That's not terribly interesting. But, well, I'm not going to go through the whole function. So back to solving our PDF problems. This solves our PDF problem. Basically, we can make a straight-up request to the PDF generating service and say that we are expecting a blob back. And we don't really have to care what it is, because it'll just give us a blob. We can slap an application type on it so that when we try to pass it to the browser to open, it'll know what to do with it. And then create object URL is interesting because it will create an object URL. Imagine that. But it'll give you a new blob URL scheme that you can assign these URLs to images, or if someone drags JavaScript into the browser, you could open that just as JavaScript. And so if you have the following markup. It'll create an href with just this blob, and there's an identifier for it. That's great because let's say you have a web app that has a photo gallery, and you want to add images to the photo gallery, and you want to crop them. You can use those data URLs to access that data locally and make sure that it fits in with the photo gallery before you send it to the server. Because if you remember, like in the olden days, you would have to upload each file before you could crop it. And that sort of invades your privacy because maybe you don't want to upload the whole image. You want to crop it. Another interesting example is something I wrote. And this is a TrueType font engine written in pure JavaScript. So this started because I saw on Stack Overflow someone posted, like, I have this problem because I want people to be able to upload fonts, but as you know, font files are typically cryptically named. I don't know what they mean half the time, but usually I just want like the name of the font, who made it, and optionally the license. And there were a lot of people who said this can't be done in JavaScript. Obviously it can. So this really piqued my interest. So I will, how do I open this into, here we go. I'll just show you, an actual example of this in action. So to handle the drag and drop, it's pretty easy. You just have a handler for that. But then once someone drops it, there's some amount of jQuery, but basically we get the where is it? The file. We can get the data transfer files, iterate over them, and then pass them into my function, which is super long. But basically, it creates a file reader. It reads it in. It parses it. And I mean, it parses it. This is actually a great use case for asm.js. I wish I had that when I was working on this. And then you can see if you inspect this, that's not like text being outputted. That is an SVG. So I pulled out all the glyphs. This works basically in any language, in any font. And so if someone is trying to upload a font, you can give them a quick screen or a preview of the font, as well as the license. So if you have user-generated content, you can say, this is the license that this file says it has. Check the box to say, I agree to this, or I promise I'm not breaking this. So, yeah, that's my presentation. Some sources. The W3C has the file API published. It's not too long. It's easy to read. The typed arrays are new. Some updates to XHR. The source is on GitHub, and you can follow me on Twitter at _QXB. Are there questions?
So how long did the pontificate take you to write the parser?
An afternoon. No, seriously. When I started my new job, the project that I was hired to work on hadn't started development. So I had like a week where I had nothing to do. So I was like browsing Stack Overflow. And I was like, I wonder how hard it would be to pull metadata out of a font file. And then that quickly went into, I wonder how I could preview this. And then the next thing I knew, I was writing like a full-blown engine. Any other questions about binary data in general? Or any JavaScript?
Yeah. I take it you didn't have to like figure out some proprietary binary format to kind of pick apart the true type files. I don't know what those contents are.
So the true type file standard is published by Apple, and the open type standard has expanded on that by Microsoft. So I just pulled up the true type standard. It's freely available from Apple. I wasn't able to use typed arrays on it, unfortunately, because the font files are heterogeneous. So you can't just have like a uint 8 for everything. You know, some things are like 16-bit integers. Some things are just strings of text. So yeah, unfortunately, I wasn't able to use that feature, but I was able to use my stream reader. Yeah.
With the array buffers, you said that the contents has to be completely in memory the whole time.
Yeah.
Is that browser dependent on how they choose to handle that? I mean, could they memory map a file, for example?
They might be able to. In particular, the API that I was dealing with has like an onload function, so it loads it into memory. I believe that with the current spec, it has to be in memory. But that, yeah, browser implementations vary.
Do you have problems with the UI locking on that side? If you're loading a bunch of data in memory, like, you know,
Yeah, well, probably. I generally don't use systems that have like less than 8 gigs of RAM. So it's not to sound like pretentious, but yeah. So I haven't had problems. I'm sure that is an issue. Fortunately, with like the file API, you could grab a file pointer and just use the file, and that could be like a 10 gig file, and that doesn't have to be read into memory until you use a file reader.
And don't web workers kind of like allow you to unblock UI do those get farmed out to threads?
Yeah. So once you like load a huge file, you can break it up and pass it off to web workers.
And you can just start slicing and dropping, right? You can, like, yeah, you have to load everything into RAM, but you said you can slice the array buffer and drop those.
I think you probably could like get progress events, and then I also used this. I was writing an email client like Gmail, so I had a background file uploader that could like keep track of progress in the background. Yeah.
You don't have to go into it too deeply, but after you parse out the data from the ellipse out of the true text front file,
Yeah.
how do you convert that to SVG?
So a glyph is basically it's like a path. It's a series of points, and with slight additional information, it's actually very similar to SVG paths. So there actually is like a one-to-one mapping. I left it, but the like to SVG function is pretty
like
simple.
One specific method call that's not native to JavaScript that kind of converts like that binary data into something that is SVG.
No, I actually have to read in the glyph, which starts as binary data, read a series of points, and then convert that to a JavaScript object that I then.
Doing like manual mapping.
Yeah.
Similar related, blobs and array buffers don't have an actual representation in the browser, but base64 does. So how hard would it be mapping then, let's say, the blobs into base64, let's say just not SVG, but PNG?
So if I'm understanding the question, how do you take a blob and convert it into a base64? Yeah, there's a really useful function called read as data URL, and that will basically be the same as this function that is read as array buffer, and that'll pass your callback a string.
So it's already built in.
Yeah, that's already built in. Any other? Oh,
Just with regard to locking up, I built a ID3 v2 tag reader JavaScript like a few weeks ago, and I was pushing the limits of like what you can upload into a browser, and I never had problems with it.
okay, cool. Thanks. Anything else? Okay. Well, I guess I'm done. Thank you.